But what you're going to see is equations that look like this. Again, I would call this a formula. An equation's fine because it does have an equal sign. I'm not going to solve this yet, but I just want to point out what they're going to look like, okay? Now, on the assignment, because this one says to solve for r, on the assignment, if you see, for example, like this one, r, 2 times. So let's say, for example, it said solve, we use a different one, solve for a, okay? So if it said solve for a, but you end up with 2 a's in the equation, what you're gonna wanna do on the assignment, just skip that. We're not gonna go over that kind of stuff today. Perhaps later in the year we will, but right now we're not. So if you saw something like this, like 5a plus 3, well, we'll do ma, I guess, equals, doesn't matter, negative 8p. If you saw something like this and it said solve for a, but you have 2 a's in the equation, just skip that problem, okay? So you just say, see the solution. Don't worry about what it says because, again, I'm not worried about going over how to solve these yet. But just understand we expect you to skip these, okay? But if it says something like this, solve for r, there's only one of those variables in here, that's good. We can solve those. So what is a solution? A solution is a value you can replace the variable with that will make the equation true. But now we're going to see that you can replace the variable with formulas or expressions, which are not just individual values. So that's the main difference today. The answers, and this may seem weird for now, the answers are not going to be just individual numbers. It's going to look like an expression, okay? So expect that to happen. And yes, as usual, we will be using principles of equality. We use addition and subtraction principles of equality to make zeros. We also use these principles of equality if we see addition or subtraction in the problem, right? So if we see addition and subtraction in the problem, automatically we would know that we need to make zeros. But the difference is, and it's just like we saw in the bell work, we may have to make zeros out of x terms or just variable terms. So expect that to happen, but we'll know we need addition or subtraction if we see addition or subtraction in the problem. If we see multiplication or division, and you'll have to remember that multiplication is not always shown, it's the only operation that is not always shown, but we're going to use multiplication or division principles of equality to make ones. Now, it's not just the coefficient that may become 1 in today's lesson. So I'm not going to type in here that we're going to do it with just coefficients. No, it may happen with just factors that are in the problem. So expect that. So today, yeah, we shouldn't expect to see any distribution or combining like terms. We may see parentheses on the problems, but we're not going to do distribution because we're not really concerned about that right now. You may end up doing that in the future, but not in today's lesson since we're just kind of being introduced to these literal equations. Now, another note on making ones is, like I was saying before, you may have to take an expression like, let's say this one, 3x plus 8, and you may have to make it a 1, okay? Like if it said, if we had something like this and it equaled something else, what you'd end up having to do is you'll have to show divide both sides by 3x plus 8, okay? Because that would force that to become a positive 1. So you can divide expressions by themselves. Anything divided by itself is a 1, and we'll have to remember that on this assignment. Also, in the past, what we've done is usually make zeros and then ones. In today's lesson, sometimes every once in a while, you may have to make a 1 and then a 0. So keep that in mind. But this idea right here, it may be very new to you, but we're going to see how to use it and when to use it. So solving equations, again, we're skipping distribution and combining like terms. We shouldn't have to worry about that. But we will be using principles of equality. Again, it's not necessarily in this order anymore. So force zeros, force ones. Again, sometimes we may have to do these in reverse order. So we don't need to number these. But in the end, what we do want is a coefficient of the variable we're solving for to be a 1. So here's that example we saw. It does say up here, go ahead and solve for r, no problem. I found r right there. Now this is going to take some thinking, right? So we got to look at this and think, what do I want out of this? Well, since I'm solving for r, what I'd like is for my final answer to be 1r. And in fact, the coefficient of r right now is a 1 right now. So if I can just take that and drop it, then I'll be done with the problem, right? Which means that I've got this negative 8j with the 1r. It's being added since I see addition with the negative aj, I'm expecting to use either addition or subtraction principles of equality. So with that, I take that negative aj, I'm going to zero it out with the addition principle of equality, which means if I do it to one side, I gotta do it to the other side. Now, this on the right side, let's just focus here. I got m plus aj, right? I cannot combine these, which is why I've kind of offset the plus aj. I haven't stacked it right underneath the m, so I know I can't combine these. You can't combine these because they're not like terms that you can combine them. So don't combine them. Keep them separated, and when you keep them separated, it will drop as just, we can just drop the m, and then you'd have that plus 8j, right? Well, what about the negative aj on the left? That's zeroed out, just as we planned. Okay, so this right here, we have 1r equals m plus aj. It's 1r. Okay, so that's what it was pretty much asking for in the beginning. And if you wanted to see that 1, you could put it there. It was there the whole time, you just couldn't see it was a phantom 1. But this is our solution. And if you went into the equation and you said, I'm going to replace r with m plus aj, you'd get the negative aj and the positive aj to zero out, and you'd get m equals m. That's a true statement. And you'll see that it's going to be true on all of them. I'm not going to go through the checking of these, but as long as you're doing your principles of equality, you should be in good shape, okay? By using these principles of equality like this, in whatever order or which way we want, it's really just to make equations be what we want them to be. For example, if you had an area formula for, let's say, a triangle, you could solve for the height of that triangle in the formula. You don't actually need values to solve for the height. You can manipulate the formula just like we're doing here with principles of equality, and then make your own new formula for height of a rectangle.